Derivative. So what are derivatives? Let's do a quick review. So we did some history. That's in the past. We did some investigation, found out the gradient function, the derivative of the parabola x squared is 2x, right? Double the x value. But that's just exclusive to y equal x squared. If I change anything else, the gradient formula will change or may change. And then find out that the gradient function for the linear function, this horizontal line, and this line can be found easily without calculus. But then we can express using the derivative notation. Okay, that's cool. And remember, whenever you substitute the number into the derivative, it tells you the gradient of the tangent at a particular point. Hence, it is the gradient function. So the gradient function simply maps the gradient, the x value to the gradient. Yeah, okay. And we also found a nice formula for the gradient of the semicircle. Some of you have done the enrichment question, which can be challenging, but if you got it right, that's very good. And instead of doing this, so basically we did it geometrically. So far, with lines, we can measure gradient geometrically. We can measure the gradient geometrically for a circle because the radius and the tangent are perpendicular. Just double check it's recording good. Today, what we're going to do is we can't do that geometrically for a parabola yet. So what we're going to do, we're going to do some experiments. Again, we started with investigation, started with small step, and then we can leap forward. Let's start with this simple idea. So let's look at the limitation with the geometrical way of measuring tangent. We pick a point, for example, 1. We have to pick a point maybe 2, right, or 3. Let's say 1 is 4, 2 is 7, right? So we can measure the gradient. And we know the gradient is going to be 3 because 3 over 1, right? Pretty straightforward. That. However, with a curve, I pick another point, 1 and 2. It is not a tangent because I want to find a tangent at 1, right? But if I find another point, it doesn't end up to be the gradient of tangent, isn't it? See, right? It works with the line because the gradient stays the same, but it doesn't work for a curve. Okay, well, but at least it will give us an approximation to the gradient of the tangent. So as you can see in the following, let's say we choose 2. So this is 1, 2, comma f2, right? We substitute 2 to get the y value. Remember, f of x is x squared. So therefore, let's see my working out. So the gradient of PQ, so call that Q, gradient of PQ will be y value minus, yeah, like that, yeah? I deliberately included that because it's going to be the same for other formulas because function doesn't have to be x squared, could be x cubed, could be anything. So we'll start with the general formula. And then now what's f of x? F of x is x squared means I'm going to square the input to square the input 1. And if we do the calculation, you will get exactly 3. So the gradient of that secant is 3. But still, it doesn't give me the gradient of the tangent. But at least we'll know it's going to be somewhere less than 3, isn't it? Because it's not as steep. Can we improve the approximation? Yes, we can. So instead of choosing 2, let's choose 1.5. It's closer, isn't it? Right? If I draw the secant, it will be much closer, more closer to the gradient of the tangent. So this is Q, once again, 1.5, comma, f of 1.5. All right, pretty cool. We'll do exactly the same thing, except the approximation will be more, will be better. We'll do exactly the same thing. All right, let's see what answer you give us. It will be less than 3. It will be less than 3, and this one you will need to use a calculator. I mean, you can do it without, but you should use a calculator. Actually, I could do it in my head, 2.25. Remember the trick I showed you yesterday? 2.25 minus 1 is 1.25, double 1.25, 2.5. See? But you don't have to do that. You can use a calculator. 2.5, all right. Gradient is 2.5. It's closer, but it still doesn't give me the gradient of the tangent. It's getting closer to that gradient of that pink line, but still not exact. So we can make Q closer again. right? We can make Q closer again. Look at this. It's almost a tangent, but not exactly, but it'll be very almost the same. Almost. Let's try that. So go Q is 1.2. Okay, 1.2. That's pretty okay, but it was just doing the same thing again. Gradient of PQ. Let's try that. Gradient of PQ. F of 1.2 minus F of 1 over 1.2 minus 1. Let's see what we get. This one, actually, I could do it without a calculator, but some of you, actually, I could, because that's 1.44 minus 1, 0.44 over 0.2, 0.40. Actually, that get be hard, but just, I think the answer is 2.2 because I got the answers here. Okay, cool. So it's 2.2, isn't it? So we can make Q as close to P as we like. We could choose 1.1, 1.01, and eventually you'll get the gradient of the tangent by making Q as close as we like to P, as close as we like. That's the idea of calculus, making things as close as we like, which for people 200 years ago, it's a bit hard to imagine. When I learned it when I was in year 11, I found year 10 as well. Year 11, I found it very hard to imagine. Like, it's so small. Like, you get what I mean? It's very hard to imagine, but yet it's true. It's true. Okay, so if you keep doing that, eventually you get the gradient of the tangent. You will get gradient 2. So, and which is what we expect, isn't it? The gradient of the tangent at x equal to 1 is 2 from yesterday. Okay, so the gradient of PQ approaches 2. I do have an animation, which I forgot to include. Actually, luckily, I've got a USB. Let's pause this for a moment up there. Okay, watch. Oh, I could make it bigger. Does it go bigger? Doesn't work. It's a bit slow. Right. Continue. Watch this. This is the secant PQ. To get the gradient of the tangent, sit down. We're going to make Q as close as you like to the point P. Does it let me move? Huh? Oh, hang on. Yeah. Like this. Yeah. See? As close as you like becomes the tangent. We'll discuss the H later on. Get the idea? Okay. Hopefully you can see. Okay, cool. All right. So we're going to continue with our saga, with our discovery. So we got something there. We got the right idea, but it's still very long. It still takes too long. Like, it's just a parabola. We have to do so much work. So if you read the following, we are now more certain that the gradient of the tangent, to the parabola is exactly 2 at x equal to 1. But not how about x equal to 2, x equal to 3. Do we have to do that each time? So we want a more formal procedure. So to find the gradient of the tangent at any point P, we need to make the second point Q as close as we like to the point P. How do we find the gradient of tangent to this thing? That thing, F5. So we need a more formalized procedure. In that case, we just per-numeralize the numbers. It's not a word I just made up. So we just, instead of numbers, we use per-numerals. It's like programming. If you insert some per-numeral, you can start to vary the values. So to describe the process of moving, again, we can move Q mathematically. As close as we like to P, we need to define a new variable, which we call it H. This will allow us to adjust the gap, right? We need to be able to adjust the gap between the P and Q as shown in the diagram below. All right, so how does that work? We still start with the point P, 1 and F1. So this is 1. And then what we're going to do is to move forward H units. This is a per-numeral, 1 plus H. H allows to be varied, right? We use per-numeral, right? That will give us the freedom to move things. So this point, 1 plus H, and no surprise, we substitute F of 1 plus H in there. Pretty straightforward. And let's calculate the gradient of that secant again. We now have a formula for the gradient of the secant. So the gradient of PQ, one more time, is exactly the same thing. plus h minus 1. So difference of the y over difference of the x, you will see is over h, f of 1 plus h minus f of 1. Yeah, got it? So that's pretty cool. Now we have to do some algebra. But I'm sure you can handle it because f of x is x squared, means whatever's in there, you substitute into h squared. Right? Pretty straightforward. Now we need to remember, how do I expand this? Well, if you remember your perfect square formula, it's very easy. Hope you remember that. 1 squared plus 2h plus h squared minus 1. All right, something exciting will happen. Ooh. We're waiting, would it be successful? Because it looks so complicated. Will it succeed in the end? It will. Because now you factorize the h out. And miraculously, the h got cancelled. You get 2 plus h. That's the gradient of the secant. Right? Now let's look at this thing. Gradient is 2 plus h, right? Let's go back to the example before. What was the h value here? What was the gap? Who can tell me the gap? The gap h, what's the gap here? 1. If I use the formula pq plus 2 plus h, does it give me 3? Oh my god, it does. The gap gives me 3. So it's true, isn't it? What's the gap for the second one? 0.5. Does it give me 2.5? Yes, it does. Gradient PQ is 2 plus 0.5, which is 2.5. That's why I know the answer. Not that I looked at my answer. I know it's going to be 2.2 because the gap is 0.2. And with all your common sense, if you want the gradient of the tangent, what gap do you want? What value should h be? So 0. That's it. Make the gap 0. Get it? So now, again, mathematician want to formalize the process. It's a language. How do I express that? We take the limit as h approaches 0. Get the idea? Of gradient PQ. That's when we take the limit h approaches 0. Do not abbreviate anything. It's already abbreviated. It's the most abbreviated language in the world, I think. It's abbreviated word for science. And when you substitute 0 in there, 2 plus 0, you get 2. No surprise. Now we're more confident that we algebraically prove that the gradient of the tangent at 1 is 2. Now it can be as bold as ever. We can apply this process for anything. We can now further generalize this process. We call this formula the differentiation by first principle. I haven't said that yet. Okay, so we're going to take the limit, calculate the gradient at any point. Doesn't have to be 1, could be a. So we'll do limit as h approaches 0, f of a plus h minus f of a over h, right? It's exactly the same as that guy, except I changed 1 to 1 to a, right? 1 to a, right? That's how easy to generalize in maths. We start with numbers, then algebra. So if you need to know good at algebra, you need to be good at numbers. And if you want to be good at calculus, you've got to be good with algebra. Yeah, so any question? And now we're going to become powerful. Let's put this to the test. Next page. Find the gradient of the tangent at that. Well, we know it's going to be -4, right? But we want to use that formula. Let's try that again. Remember, f of x is x squared. Let's formalize the process. You need to show this working in the exam. Do not skip working. Do not abbreviate anything because you will get things wrong. F of -2 plus h, I'm just using the formula, over h. I could find the gradient at any point. Let's see if it gives me -4. Hopefully it does, if your algebra is correct. Limit. Notice that I have to keep writing the limit until the last step. And it is necessary. Bracket, -2 plus h squared minus -2 squared over h. And we keep going. Lim h approaches 0. Square the thing. Be very careful. This is -2 squared. Yep. Yeah, go. right? Yeah, you can watch the video later. later. Okay, cross this out, and then we'll keep going. Lim h approaches 0. That will be negative 4h plus h squared over h. All right, so what do? We have to keep going. Remember, I do things slowly. You won't make a mistake. I'm just doing algebra. None of this even calculus. It's just algebra. Calculus is just one step, icing on its cake. Every step before is all algebra. Yeah? Limit h approaches 0. H out, and we'll cross out h, right? And then we'll take the limit as h approaches 0, negative 4 plus h, and then we substitute 0 in, the gradient is negative 4. Get the idea? I substitute 0 in, then I stop writing the limit. Does that make sense? So you write the 0 before, after you write the limit, and then negative 4. Which is not a surprise. It is negative 4. Remember, the function was, gradient function was double the x values. Yes? Right, so it confirms our belief yesterday. Okay, cool. Now the question is, oh, why can't we substitute 0 at the beginning? Because we have 0 in the denominator, right? We can't do that. That's why we have the limiting process. We'll do that after the h get cancelled. If the h doesn't cancel, you made a mistake. So now we say, oh, that's so inconvenient. Can we get the formula for the derivative? Not just at any point. Well, easy. Your wish is granted. Just change a to x. So if you want to find the derivative, still make h approach to 0, but f of x plus h minus fx. How cool is that? Look at the journey of calculus. We start with something, a simple idea. It's just a matter of introducing the right polynomial. Is math difficult? Can be. Is math amazing? Yes. Is math easy? Yes, can be easy. All right, now we're going to use that formula. Now we're going to test. We're going to test. It's like Mythbusters, right? But this time, there's no myth. We know it's going to, if you bet your money in maths, you will win 100%. No probability. Now watch this. We're going to find the derivative. Let's see if it's 2x, right? Lim h approaches 0, f of x plus h. This is called the differentiation by first principle. And then you think, oh my God, I could differentiate any function, which we'll do later on. But let's make sure the x squared is correct. Limit h approaches 0. X plus h squared minus x squared over h. Right? Nothing. Remember, 80%, 90% is algebra, 10% is calculus. Does it make sense? Yeah, it's mostly algebra. So if you're poor with algebra, make sure you revise everything. Seriously, it's all algebra. And in fact, it's so easy because you did it so many times numbers. It's the same thing with polynomial. It's like when you watch a movie 50 years ago and 50 years from now, it's the same movie, it's just different characters, more color, more explosion, whatever. You know what I mean? It's the same thing. Same with maths, it's the same thing. Get it? All right, let's continue. This is so exciting. 2x plus 2xh plus h squared over h lim h approaches 0. H 2x plus h over h. The h get cancelled. Very important. Always factorize the h out. If you can't factorize the h out, you're in trouble. And notice that the x squared term always get cancelled. In fact, the only terms that survive is the h terms. All right? Okay. Again, you have to be patient. Do one step at a time. And then substitute 0 into h, not into x, into h. OMG, it is 2x. We proved it. We proved it. Not by experimentation, not by numerical data. It's empirical data. It actually works. But, oh, that's a lot of work, yeah. But now we can find the gradient formula. It's like a small step, but huge step for mankind, right? We can differentiate a lot of things. Now we become powerful. We can analyze a lot of things. Before it would seem it's impossible to find the gradient of a curve. Now it's just simple matter. We've got this machinery, that's called calculus. We're calculating gradient. Okay, now let's We can use it to find the gradient at any point. For example, f of x is x squared. F dash of x, the gradient function, allows us to find the gradient at 1, gradient at negative 2. How cool is that? This is cool. It's better than a video game, right? Because it actually gives you something nice, as expected. All right, well, we feel powerful. We just validated our belief, but that's not enough. We need to check it that it works for anything for us to believe, right? Okay, cool. Let's move on to the next page. Hopefully you're ready. Okay, would it work for this guy? We know it's going to be gradient 3. Well, there's only one way to find out. Lim h approaches 0. But this time could be inflexible x plus h minus f gx. You want to have a try? See what you get. If you didn't get 3, you know you're going to get it wrong. It should work with anything. That's why it's called differentiation by first principle. It works for anything. Okay, watch this. This is so cool. After calculus, I start to fall in love with math. This is the best. All right, remember, it's substitute that thing into x, right? Minus the g of x, which is 3x plus 1, right? So remember, this is g of x. This whole thing is gx plus h, where the x value got replaced by x plus h. Now it becomes a question of algebra. That's okay. Let's use algebra. Expand this 3x. Oh, by the way, math is very multicultural. It is still multicultural. People have to bring different ideas across the continent to do research in maths. Notice the algebra are invented by Arab. Calculus are invented by the European. We combine the two. Right? Get the idea? So mathematical research is the most, you need to collaboration. See, before I just think I could just sit at home, do my own research. You got to look at other people's ideas. I just think, oh, math's easy. I just stay at home and just, but someone may discover before you, or someone may have different ideas to help you. Yes, it's very multicultural, it's universal language. It's amazing, yeah. And then H got cancelled as expected. Oh, that's unusual. We've got nothing to substitute. That's okay. As x approaches 0, 3 is still 3. Doesn't matter. As expected. OMG. It's long, but now we can prove it. Cool. All right. And the next question is, would it work for x cubed? Of course you will. This question will be addressed in exercise 9b. So when you do exercise 9b question 10, you get to do that. But I'll leave the excitement to you. But let me get you started. So you just go, k dash is lim h approaches 0. K x plus h. K dash is like Kim Kardashian. All right. You know what happened? I was there planning to use H, but I just realized there's a H there. I can't say that. That will confuse people. So I edited it in my new. Well, yeah, I test drive it before I did it, so that didn't happen. Okay, so you get that. Now I will leave the excitement to you. So the question is, how do I expand this? You can do that in your book. You just have to do this. I think we did that in the first chapter, algebra. You just have to go x plus h squared, expand this, and then expand more. Yeah? All right. Dot, dot, dot. Okay, we have to move on. And also, in addition, you do that later in the exercise. The question 10, question 11 and 12 will address even more complicated guys, like these guys. Right? It's very exciting. All of a sudden, we can differentiate anything, almost anything, almost. Algebraic function can differentiate. You can do that all day at home. You don't need an Xbox. You don't need a thing. Just do that. You feel, oh my God, you may even discover something. But anyway, let's keep the excitement later because I do have to move on to one more page. Okay, so far it's just one term. X cubed, x squared, x root x. What if there are 3 terms? 2 terms like that? Well, let's review our function notation. How do I do that? F4. Pretty straightforward. F of 4 means I replace x by 4. That's all that means. I think the answer is, all right, if you use a calculator or just copy that, you get that. Oh, what if it's 1 plus 3? It's exactly the same thing. 1 plus 3 is 4. You just have to go 1 plus 3 square and then 3 times 1 plus 3. Hopefully it makes sense, right? And these guys becomes 4. Does it? Right? So each time you see x, whatever's inside, replaced by whatever's here. Does that make sense? So it's like the function notation. The box is a container, square minus 3 container. Get it? And that container can stretch as large as you want. Remember, it is the maths. Anything could happen. Watch. So that means x plus h squared minus 3x plus h. How amazing is that? Okay. What do I do? You have to expand, etc. But we're not going to do that. We're going to do that for this question. Actually, we should do that because you get some practice. Practice makes perfect. 2xh plus h squared minus 3x minus 3h, right? And then you're going to, oh, there's no like terms usually. I don't think there's like term for that. Yep. All right. Let's work with this. It's more complicated. The algebra will be more complicated, but it's the same process. Let's see if it works. Let's see if it works. Okay. All right, let's see. F of x plus h minus f of x over h. Pretty straightforward. And then we're going to substitute. Oh, okay. That's pretty easy. We just did it over there, right? We just did it over there. Give yourself more space. Watch. Remember, 6x, the container will be replaced by x plus h minus x plus h squared. Remember, this whole thing is this thing. Get it? I know it's confusing for some. When I teach, people just get confused. But again, make a conscious effort to make this connection. Minus f of x is the original function. Notice that I use a bracket because you're not just subtracting this term, you're subtracting both. If any algebra is wrong, the whole process will stop up. So the first step, notice that I show you all the steps. Always start with the formula, then the substitution. Do one small step at a time. It's less risky. You will eliminate, you will not eliminate, but you will minimize your careless error. It's about the habit, right? The right habit. Watch this. Expand this. 6x, 6h. Minus. Be very careful. Alarm clock rang. Minus bracket. Do one thing at a time. Expand this. If you rush, you will get bad. I mean, some people can, but they probably have done lots of algebra questions in their whole life. They could just do it in their head. But I don't recommend it. Yeah? Do one thing at a time. Seriously. I know, when you're teenagers, when you're young, you rush. Right? Especially when you're young, you rush. You can't wait for the result. You want to get everything. But everything comes as a price, right? You do have to put in effort. Minus x squared plus minus 2hx minus h squared. Notice that takes so much time. It's like cooking for a dish. Take the time to prepare. Stir fry is the last bit, right? It's quick. Yeah? Watch this. The x squared get killed. You expect any term with x only gets killed, right? That's the general idea. You should expect to find anything without a h will be eliminated. If not, you made a mistake. All right. We keep going. We're doing it slowly but steadily. H, 6h minus 2hx minus h squared. You do need to do a lot of practice. If you don't do the homework today, you will struggle tomorrow or the day after. Yes. All right. And what do I do next? I want to ask someone. Hopefully still awake. Irene, what do I do next? Look at this. What do I do on the numerator? Excellent. Good answer. Let's do that. take the h out. It's the same thing. It's the same thing. Seriously, some people say maths is easy. It is easy. Once you know what you're doing, it's easy. Once you don't know what you're doing, you just feel like pray for something. Okay. All right. H get cancelled. And up to this point, you can just put 0 in, right? 6 minus 2x minus 0. You can skip that step, but you don't have to. 6 minus 2x. Yeah. So you can actually revise a lot of algebra when you do calculus. You get to revise a lot of algebra. Okay, now, hence find the gradient at 2, right? So the gradient at 2 will be f of dash of x is 6 minus 2x. Yep. 2 is 6 minus 2 times 2. The answer is 2. Gradient is 2. Notice that the rules still work. When you see the x squared, it's still 2x, right? We can actually do them separately. 6x is the gradient of 6, right? But we'll discuss more about that next lesson when we look at a rule. But now, for now, just do this procedure. Do not skip step, because you will get things wrong. You lose the mark in the exam. Part C. We can also go further. Once we got the formula, we can sketch the graph. But we'll first find the point where the tangent is horizontal. If the tangent is horizontal, what's the gradient going to be? Anyone? 0. So that means f dash is 0. We have to find the x value. It becomes an equation. What was f dash again? 6 minus 2x. OMG, that's easy. What's x equal to? 3. That means at 3, the gradient is 0. Let's sketch the curve. Let's see if it's true. Now we can sketch it. That's a parabola. We can't sketch parabola now. You just find the x-intercept. Watch this. Is it concave up or down? Down. And not surprisingly, it does tell us the truth. The calculus say at 3, the tangent is horizontal. Yes? Yeah? Tangent is horizontal. You can work out substitute 3 and you get 9. Right? That's the idea. We can use calculus to do so. Once you know how to find gradient, it's almost like you found a new country. You can do almost anything. All right, any question? Any question? Today you're going to do that exercise right now. Why stress in your brain? If you wait till tomorrow, what do I do? It looks so complicated. People say strike the iron while it is hot, right? Yes. Got it?